Hello, and welcome to this presentation on domain facades and essentially layered architecture and where or why to apply a domain facade design pattern in your layered architectures. In this presentation, we'll cover what is a domain facade, why should I use it, what does it do, what are its jobs and responsibilities, and how do I ensure that I'm doing the right thing. Frequently, with a lot of these design patterns and designs in general, there's the design pattern and its motivation, and then there are implementations. Not all implementations are correct. As a result, some people either misunderstand the design, such as the layered architecture pattern is, I think, grossly misunderstood or misrepresented / implemented. And in this presentation, I want to talk to you briefly about what are some of the ways in which you can ensure that you're doing the right thing. And lastly, to SOA or not to SOA. A lot of architects ask this question, at the beginning, trying to determine what their application should be or how their application should be deployed. And my response is, who cares? Does it really matter? Should it matter? Should your designs be such that they are tied to one way of deploying or another way? Can you choose to deploy your applications, let's say, in a non-SOA deployment or a SOA deployment or a hybrid of the two? We look at some of these techniques in this presentation as well. So before we move on to some of the innards of this presentation, just wanted to clarify that the domain facade has got various names. I'm not sure which one came first, the domain facade or the service layer or the application boundary pattern. Nonetheless, what I see here is, or what I show you here is that the domain facade is known by different names. The service layer was coined by Martin Fowler, who in turn got his motivation or ideas from Alistair Cockburn, who called his pattern the application boundary pattern. The Ruby on Rails people, or the Ruby community, calls the same pattern the facade controller or domain controller. The controller is not what you would call a controller in Rails or even in ASP.NET MVC. The controller in this case is more of the sort of the English meaning of a controller, something that controls the domain, or if you will, the facade. In IBM, they call it the service facade. So all of these are different names to kind of mean the same thing. The service layer, unfortunately, to me, is an overloaded term. So when I say service layer to people, it has many meanings to different people. So I tend not to use that name. The domain facade, I think, is so far the most understood, I think, to me, the name. So I'm going to go with that name in this presentation. So let's talk about why you should use the domain facade. The domain facade essentially provides you with a few virtues, with few benefits. One of them is it provides a very defined application boundary. So if you had an application over here, and I'm just going to do some boxology, and you have a facade in here, this facade becomes the boundary, meaning this becomes your sort of input, and therefore this becomes your public surface, your public API. And this facade provides a very nice, clean boundary to your applications. Facades can be used across layers as well, so every layer potentially has its own facade. And so for every layer, the point of entry is what I call the point of impact, which is, it doesn't go any further than this. Things can't go beyond the facade, they can only come up to the facade. And that's where the boundary takes place. From the jobs and responsibilities of the facade, it coordinates, it orchestrates. I call it orchestration, really. Within the facade or internal to the facade, there are many classes the classes actually know how to do the stuff. So I call these classes managers. So the managers are, so if the facade was a director, the managers are then the managers in terms of a typical organizational structure. You have directors, then you have managers. Managers have leads, and so on. There's various other people within the teams. So the facade is your director. The director has many managers at his or her disposal. The director doesn't actually do stuff, but he or she orchestrates with the other managers. So when something needs to be done, the director will enlist the services of multiple managers and coordinate between these managers and get the job done. That's essentially the primary responsibility, or the only responsibility of a facade. But this design pattern has another virtue, which is it allows you to evolve the core without changing the API. So let's imagine for a minute that this is your version 1 of your application, and you've defined this API on this facade boundary here. So the public surface of the facade has this nice API that is very business specific and works for the business. Behind the scenes, you could implement this thing as just let's say structural code. So there's no objects here. You haven't decomposed the implementation enough to even form all these objects that I'm drawing here. It's just a bunch of structural code. Then in version 2 or 1.1 or whatever the next version is, you now have the opportunity to start decomposing some of the functionality as you understand them better into better objects and classes that you might want to reuse or use polymorphically. But the benefit here is that the public API is untouched, and because people can't cross this boundary into your layer. This is a key concept. It seems actually pretty simple or pretty obvious, but I have seen a lot of code that calls this a layer. So this could be an assembly of some sort, and there's a bunch of classes in here, and the consuming application or consuming system is going going to town on this assembly from all directions, is accessing every single thing that's possible in here that's public. Now it becomes impossible for you to evolve your core, because your core is completely exposed. So one of the great benefits that the facade provides you is that the core can evolve independently of the API. In fact, I would say that the API is relatively stable for the most part if you've done your analysis well, but the core is constantly evolving, and that's what the facade gives you a really clear advantage there. As a result of this public API, the facade obviously makes available the set of operations. So in this scenario, no, not in this scenario, but because of this specific fact here, you have to be really careful, because it becomes the sort of the heart and soul in terms of the API, the public surface of your system, and yet you could abuse that fact, meaning the facade now starts to become the all-knowing, all-doing kind of class, the cliche being the God class, and that's almost like a runaway train from a facade standpoint. So you have to be careful that the facade is doing this one job and one job alone. It's not doing more than this, and its real purpose is to define a boundary or a set of available operations. So let's look at the concept of, at least from my perspective, the concept of a layered architecture and some of the rules, if you will. I'm making this kind of probably an obvious point to some people or most people, but I've seen that many people I work with don't understand this concept. They do use the word layered architecture as if giving a name to an assembly was the layer. But I wanted to here in this slide just demonstrate some of the rules that I kind of follow. So here we have this service interface layer, which is essentially anything such as an MVC controller, an ASP.NET web form, a web API controller, a SOAP service, what have you, something that is doing the service interface. Okay. The next layer is the domain layer. We're all familiar with this, the business layer / domain layer. Different people call it different things, but essentially it's the same concept. And then you have a data access layer. Now, most times I find that a typical business system has these 3 layers. So there's no problem here with this concept. Beyond this, there are problems. So now it comes down to the implementation details, or it comes down to that last mile where it's kind of like Google Maps. You get directions to your some office where you got an interview or something with, and it's that last turn, last mile, last light, and you're totally lost. You got gazillion options, and because of your state of mind, you haven't a clue which way to go, and you turn one way, and obviously it's very rarely the right one. That's kind of like how I feel with a lot of the design patterns. There's the motivation, there's the explanation, but when it comes down to actually implementing, a lot of people go astray. So I want to kind of clarify some of that over here. See, so some of the rules that I follow is: 1, a layer to the left can only talk to a layer to the right, meaning this is the sort of the starting point, left to right. The layer on the left can't go across layers. The layer on the left can't go into this layer either. So it can only touch the surface, the boundary. It can't talk to something on the inside of this layer. It can't go across this layer, can't hit the boundary, or can't go into it either. So basically the layer on the left has got one choice and one choice alone, and that is to talk to the boundary of this layer. This layer in turn can only talk to one layer down and to the boundary. So there's 2 sort of rules, if you will. One is each layer can only talk one layer down, whichever way you want to call it down, top to bottom or left, right. And they can't cross over to other layers, and they can't go into a layer. Okay, so that's kind of very simple rules, very simple concepts, but that's essentially what in this presentation, that's what I'm trying to kind of impart. The other way to look at it is that this boundary here that you hit from the outside, it is your facade, right? So if I could just draw a straight line here, so that's your facade. And so when the layer on the left is talking to you, is talking to your facade. The facade provides it with that public API, and it provides it with the coordination, orchestration that needs to be done within the gazillion of classes that are in here, that this domain facade might use, the domain layer might have, and the domain facade uses through its managers and sub-managers and so on and so forth. So there's a bunch of classes here. Every layer potentially has this notion of a facade, and the same sort of concepts apply. Facades make use of managers, managers make use of other services, and various other things. So I'll go into more details here, but that's really the concept. So if you get this concept, we can now move on to the next slide, which is slightly more complicated and a little more detailed, but it's the same concept, just more in a sort of an exploded fashion, exploded view of things. So here's your service interface layer, which is again the same. It's the web API layer, it's the MVC controller or ASP.NET Web Forms layer, the SOAP service layer. The domain facade is internal to your next layer. In this case, this green box here is the next layer, and the domain facade is the point of entry and the boundary. The domain facade depends on, so now these arrows are showing dependencies. So the domain facade depends on these managers. Managers are its sort of first and only line of defense. The only thing that domain facade really talks to directly are these managers. So it is actually coordinating and orchestrating between or across these managers. So one manager doesn't necessarily know that the other manager exists. So that is the siblings in this case don't know of their existence. There's no connection across these managers. The domain facade is the only one that knows of the existence of all of the managers, and therefore it knows how to do the coordination. It says, okay, well, I'm going to first call this manager to get this job done, then I'm going to call into this guy to do something else, and probably call into that guy to do something else, and so on. That's the coordination the facade does, and I'll show you in code some examples of that. So, and managers don't talk sideways, meaning they don't talk to each other, they don't know of their existence, and therefore there's no dependency that is like this. Managers in turn might depend on other services. So now it's not very clear with these arrows how the dependencies are going, but all the dependencies are going from left to right. So if you're seeing an arrow is actually going like that, or this one is, you know, probably going like this, and this one is going like that, and so on. None of them is actually going backwards. Okay, but that's irrelevant. The idea is that these managers have dependencies on other services. They don't have dependencies on each other, they have dependencies on other services. All of the stuff in this sort of level here is a service. Everything on this side is a service, right? So managers depend on services. Services don't depend on anything else. Now, the exploded view of a manager, if you look at the video manager here, think of this as the exploded view of the manager. So managers in turn have many other classes that might have many other classes and so on inside of them. So this pattern kind of continues on, but nonetheless the dependency always flows one way. They don't depend on something behind them or backwards. There's no cyclic dependency and there's no cross dependencies. So dependency flows left right, just like the sort of program flow, program logic would kind of flow left right. Over here we have kind of like a special case, in this case a class that is, you know, a data facade, and I've called it a facade intentionally, even though it's kind of like a service inside of here. So while it's inside of this assembly, this green box, which is the assembly boundary or application boundary, it is actually considered a service because it's kind of in line with this, but in this case I call it a facade just because it might use additional managers to get the job done. So it's kind of a little fiefdom in and of itself, and in some cases you might want to be able to split that up into a separate assembly. So this red box now is a separate assembly, and the facade has kind of just been pulled out into another assembly. Nothing should ever change in your application. The beauty of the design, or the ratification of this design, is that you can have this state wherein in this case the data facade or the data service is inside your application, and you should be very easily, within probably a few lines of code, switch it to be in a different assembly, and everything should just work. And if you're able to do that, then you know you're kind of on the right path and you're not violated any of the rules. Two rules in particular. One is you go up to the facade boundary, you don't go past it or inside it or talk to other things, right? So if you violate those over here, you only talk to the boundary, then you could easily extend this boundary, if you will, like expand this boundary, tease it apart to be outside. And that's really the concept here. So some of the tenets about using a domain facade is code pertaining to the inside part. Inside part meaning behind the facade. I like to call it behind the facade or on the other side. So the code pertaining to the inside part should not leak into the outside part. And this could have many meanings to you depending on the context. But essentially what it's saying is that how you get the job done on the inside should not be exposed on the outside. So one of the key aspects of using a domain facade is to provide a simplified interface. Typical business functions involve many steps, many procedures, validations, etc. But from the outside, you want a very simple interface. You don't want to complicate things for your consumers or for your customers. So the facade's primary purpose is that orchestration, coordination, and it does that because it's simplifying the interface on the one side to the public, knowing fully well that, you know, I'm asking you to, let's say, you know, you go up to the DMV and say, hey, get me a license, and here's the information you're asking for, such as proof of address, proof of age, etc. And a whole bunch of things happen behind the scenes, behind the counter, and then, you know, up pops a license. Of course, not that simple, but conceptually, You didn't have to understand all the inner workings of the DMV and all the other stuff that they're doing behind the scenes, but nonetheless, the process was fairly simple. And that's what this really means, that the outside shouldn't have to know what's going on the inside. Dependencies pertaining to the inside parts should not leak to the outside parts. This is now speaking to typically the classes and other things that are being used by the facade internally or by any of the managers and so on internally. So again, the outside should not be privy to or have access to these classes that are being used internally. In other words, the typical orchestration is handled by the facade, and so the outside doesn't need to know that this orchestration is done and that these classes are kind of at play in this orchestration, and this is how you have to do the validation. You have to first validate this, and you have to validate that, then you have to call this method. All of those things are completely hidden. And so the only way you can hide that is by also hiding the dependencies of the inside from the outside. Take the lines of your layered architecture very seriously. And this pertains to the last few diagrams where we saw there were layers, there were boundaries. And so I call them boundaries. Alistair calls them lines. So take the lines in your layered architecture drawing very seriously, because they are lines. They may be virtual lines, they may be conceptual lines, but they are lines and they are boundaries, and you don't cross those boundaries willy-nilly, at least. And then actually, we already talked about this. I'm not sure what it's doing here, but we shall talk about this later. So the demo of facade and service interface layer, we'll skip over that. Coordination and orchestration. So we talked about the basic coordination and orchestration, but one of the other aspects of this coordination and orchestration is that the domain facade hides or encapsulates the complexities of these operations from its consumers, which I talked about in the previous slide, which is the simplification of the interface. One of the other things that a facade might do is lifetime management. So if you notice, let me just backtrack and do some of the slides here. Okay. So if you look at this here, these services are being used by multiple managers. It's not very apparent here, but let's assume that that's the case. So the domain facade instantiates this manager, it instantiates this manager, and it instantiates this manager. But it knows at the time of instantiating this manager that there is a dependency on, let's say, the email service and the data facade. Now, what the domain facade does is it's already created an instance of the domain facade, the data facade, sorry, and the email service. So it hands this manager the pre-existing instances. Then let's say this manager also needs the data facade, but it gives this manager the same instance. In other words, there's only one instance in this case of the data facade, and so those instances are reused by the facade. So the facade is playing that role of determining the lifetimes. It's deciding that, hey, you know what, I'm only going to create one instance of this email service and I'm going to share it across all the managers that are interested, or I'm only going to create one instance of the data facade and I'm going to share it across multiple instances. Of course, this has implications to your implementation and to a certain extent the design of these classes, because they need to be stateless if you're going to be in a threaded, multi-threaded environment such as ASP.NET. But for the most part, that's not such a big deal these days. Most people are used to building stateless objects or classes, or so not classes, but subsystems. Okay, so implementing and ratifying your design. In other words, how do you know you're doing the right thing? How do you know that your design, and therefore from that point the implementation is true to the design or true to the design pattern? So there's a few ways you can ratify your design. Can you separate out your data facade and remote it? In some ways you could just say, can I separate out the data facade from the existing assembly into another assembly? If you can do that, can you then take it further and remote it? Can you do the same for your domain facade? Can you collapse all of your layers into one assembly or deployed with this with your consuming application as one assembly? Does it still work? Can you separate out individual components or subsystems to be able to scale independently, which is essentially the SOA architecture? And all of this can be actually done with some simple code generation that you can do, where you generate the service interface layer and the remote proxy class and test out these concepts. And of course, in this case, you don't need this stuff. So a simple way to ensure or ratify your design implementation is teasing apart the different layers, if you will, the conceptual layers, into physical tiers, and collapsing them into either one assembly or in-process assemblies, meaning they run in process along with the consuming application. So now let's talk about the real SOA part, if you will. So the typical surface of an application, simple application, business application, is that there's a surface that sort of adheres to or talks to the GUI. There's a surface that talks to the data source, whatever the data source is. Maybe it's multiple data sources. There's a surface that provides an API of some sort. So there's a service interface layer that either is talking HTTP or SOAP, REST, TCP, stuff like that. There's a surface that is talking to some out-of-band processes, such as MSMQ, a messaging service, or an email service, something that's typically and hopefully asynchronous in nature, notifications and things of that nature that are happening in your system. There's a surface that is sort of addressing the cross-cutting concerns such as logging and security. And of course, there's a surface that has to address the testing or testability of your application and its components. A more typical business application that's a little more involved is no longer a hexagon but an octagon, which is 8-sided. In this case, I'm only using the 7 sides. Let me just pull them up. So these are the sort of the previous aspects we saw, and I'm adding these 2. So in some systems, you are invariably talking to services that are not even owned by you. So these are truly services that are fronted by third-party organizations or business partners. So there's no option here to talk to these entities using a service of some sort. So that's a given. Let's talk about these systems. These are your internal systems, subsystems. So in this case, there's a coverage system, there's a policy system, and so on. They are subsystems that you own, as in they're part of your organization. And let's say, as an example, or for argument's sake, at this moment in time, these subsystems are running in process. So these are assemblies, and they're running in the same process space as your main application. And after a while, you decide, for a number of reasons, that you want to now take this guy and remote it because of scalability reasons, maybe reuse reasons across other systems in your application. You want to be able to reuse the services of this subsystem. So you should be able to tease it apart and insert a service interface layer on one end and a remote proxy on the other end, and have this application working. Now, this may sound very simple, and actually it really is, provided your design is good. So, going back to this question, who cares? Does it really matter to you whether you're going to deploy this application as a SOA or run it in process? I think for the most part, and I've designed systems and implemented systems like this where it really didn't matter. In fact, the system didn't even talk about being a SOA deployment, but when push came to shove, we were able to actually do this piece in no time flat. I mean, the interfaces typically are very simple, and the technology to remote something using HTTP these days is very simple. There's lots of helper classes that do the job for you, and technologies, data transport mechanisms such as XML and JSON that make it even simpler. So you could go one step further, and you could say, okay, let's remote this system as well, and you pretty much do the same thing between these two systems. You can have combinations. You could say, okay, well, this specific application is using this thing as a service and this thing as a service as well. There could be another application in your organization that houses the coverage subsystem in process but uses the policy service as a service. So there's multiple permutations available depending on load, scalability, performance, etc. So let's talk about testing now. So one of the things that might not have been very clear to you is that when you are, when we talked about some of the key tenets that Alistair Cockburn talks about in his book. Sorry, is over here. Right. So code pertaining to the inside part should not leak into the outside part. Well, that implies that you got your facade. So there's some layer, business layer, data layer, whatever the layer may be. There's a facade in here. And applications can only hit the facade boundary, right? So any consuming application can only hit the boundary. So what stops them from misusing your facade design pattern and making use of all of these classes, potentially hundreds of classes inside your business layer in this case? Well, these classes are actually not visible to them, so they're not able to see them. They don't even know they exist. When they take this assembly from you and they try to use it, the only thing they're going to see is this one class, the facade. And the only aspects available to it are the public methods of this facade class, the public surface of this facade class. So they don't have a choice but to use these classes inside. Well, if that's the case, then how do you test it? And of course, in C# there's a very simple concept to essentially make these classes all internal, so anything inside of this assembly can see them. But then your testing assembly is a separate assembly. So then, if that's the case, then the internals don't kind of work across assemblies. But in .NET, they introduced this attribute in .NET 2.0. So it's been in .NET for quite a while, quite a few years. And it's called internals visible to, meaning it's an attribute that you decorate your assembly with. It's an assembly level attribute, and it says internals visible to, and in the as a parameter, the internal visible to is as is normal with the attributes, is a constructor, and that takes a parameter. It can take in a string, which is nothing but the name of an assembly minus the fact that's an exe or a DLL. And if you want to make internals visible to multiple assemblies, then you can either repeat the attribute or put in a comma delimited list of assembly names in the form of a string without the extensions. So armed with the internals visible to attribute, it becomes very easy for you to test the internals, the classes that are on the inside. So you can do your unit testing, integration testing just like normal, yet not allowing the public consumers of your systems access to things like the data layer. Why should somebody be able to access your data layer directly? They must go through your business layer and affect all of the rules before making any data changes. So that's one of the key sort of motivations for hiding everything internal, including your data access layers. Therefore, only allowing classes, either the assembly, the internals, or these testing assemblies or test projects access. Now, if you remember the earlier diagram where we had these dependencies, where all dependencies kind of move to the right, or the flow was such that dependencies only moved, this way. So this class might be dependent on two other classes and so on. Then by stubs on the right, what I mean is that if I'm testing this class, I need to only stub this class, this class, and this class. If I'm testing this class, I need to only stub out this class and this class, and so on. If I'm testing this class, I actually don't need to stub out anything because it's not going to be dependent on this. They're certainly not dependent on something behind it. Only dependent on stuff on the right, and there's nothing here on the right. So you can test it. You just don't need to stub out anything else. And that the slide where I talk about the different the dependencies sort of flowing from left to right and not up and down and not backwards is important, because then it allows you to even test things in a very clean fashion. And fixtures on the left, meaning all your test code. If I'm testing this, the code is on the left. When you're doing your testing in your unit tests, you can make use of ISE containers such as structure map or Unity or whatever your choice favorite IOC container is, to allow you to configure the stubs that you plan to use. So I could configure my unit test, or in this case my IOC container, when I'm doing unit testing of this, saying use the real class for this class, but use my stub for this and the stub for that. If I'm testing this guy, I can say use the real class for this one, but use the stub for this, the stub for this, and the stub for this. So that's essentially, the design should allow you to do all of those things. So this brings us to, I guess, the end of this presentation on domain facades. In this slide here, you're going to see certain references, certain books or websites I have read over the years that have educated me and helped me understand the concepts I've just imparted to you. So this is Martin Fowler's famous book on patterns of enterprise application architecture, pretty involved, in which he talks about the service layer, and in which he also gives credit to Alistair for his pattern. This is a website where it actually talks about Microsoft Patterns and Practices group that talks about layer architecture designs as a whole, and this specific link talks to the business layer and the facade concept to be employed in the business layer. This is a link on IBM's Developer Works website, where they talk about, I think in this one they talk about the service facade. Both of these guys, they talk about the service facade, but different people, different articles, slightly different concepts. The Pattern Languages of Program Design is a nice book written by John Besides, I think is how you pronounce his name. He's one of the GOF, as he's one of the gang of four, who's been writing a lot of books since. So this is one of his nice books that I've enjoyed, and where I learned about his concept of the domain facade. So that's it. I hope you have enjoyed this presentation. I will be backing this up with a bunch of demos that I hope to publish separately, or maybe as one other video. So stay tuned.